All right, that's it for the rapid fire. First derivative test. Remember, I said to show that a function is increasing or decreasing, we had the algebra definition in which you had x1 is smaller than x2, then f of x1 is going to be bigger than f of x2. That's decreasing. That's how you do it in algebra. You have to show that the previous y value is smaller than going from left to right. So that's not really efficient. But the first derivative test, hopefully, is going to do a lot better and give us local max and local mins. So, with that said, oh yeah, I got another brain break today. I'll see. I haven't done one all day, so we'll try one today, and we'll go on. So the directions here are pretty much the same. Find the local extrema over the interval 0 to 2 pi. When it says over an interval from 0 to 2 pi, that means you're working within one trip around the unit circle. Hopefully the last rapid fire helps us get through this. That's why we've been doing it. And also find the intervals where the function is increasing or decreasing and sketch the graph. Okay? So, 1/2 x plus sine of x. Obviously, the first thing is to check the domain from 0 to 2 pi. And for sine, there aren't any asymptotes, no holes, so the domain's all in good shape. Not like an algebraic function. So f of x equals 1/2 sine of x plus sine of x, and I guess we'll just start by taking the derivative. Oh, you got to check the endpoints too, don't you? Oh, it says local extrema. Never mind, not regular extrema. So we don't have to worry about the endpoints. All right, so we're going to take the derivative. That's pretty obvious. 1/2 plus cosine of x. That is the derivative. Set it equals 0. Now we have our rapid fire. Where's a cosine of x going to equal negative 1/2 at? 3 pi over 2 would be 0. 2 pi over 3 would be a negative 1/2. 2 pi over 3 is one of them, and what's the other one? 4 pi over 3. Okay? So it should be 2 pi over 3 and 4 pi over 3 are the critical numbers. Now on our number line, since it's a closed interval, you have to account for the 0 and the 2 pi on your number line. That will change your intervals. This is the first time we've had one with the intervals on a closed interval doing the extrema, the local extrema. But anyway, you find them. And as long as you got the unit circle, you're in good shape. Again, your number line looks a little different because it is a closed interval. It's said from 0 to 2 pi. So on a multiple choice quiz, test, / whatever, you know your interval is going to account for that. So you just put numbers in from 0 to 2 pi over 3. I don't know. Put it in pi over 2. Yeah, that's a good one because cosine pi over 2 is 0. So the derivative is going to be positive. So that's going to be going up. Between 2 pi over 3 and 4 pi over 3 is pi. Cosine of pi we all know is negative 1. So 1/2 plus negative 1 is negative. So that's going down. And then finally, since it is, pretty cyclic, that'll be going up there at the end. We put another one in. This is when the test or the quiz or the homework says use the first derivative test. That's what this is. The critical numbers that equal 0, the number line for the intervals. It's all the first derivative test. Okay. Now you can just say that that's a local max and this would be a local minimum. The reason you say local is we didn't check the endpoints. We're not looking for absolutes. We're looking for locals. Okay? If we were looking for the absolute extrema, that's where you check the function a, b, and c. Those values. Right here, we're just doing those. And then what mode does your calculator have to be in to graph it out? Radians. Okay? So you have to be in radians for everything. All right. So increasing from 0 to 2 pi over 3 and 4 pi over 3 to 2 pi. Again, I would have parentheses. I wouldn't put brackets because, well, I shouldn't have, but the book does. I would still use parentheses. Okay? And then decreasing from 2 pi over 3 to 4 pi over 3. I'm not going to mark off, of course, but anyway, get the idea. Hey, wait a minute, what is today? Thursday? We might have a 5 or 10. It depends. What time we got here? 26? It'll be close. Not yet. We got a sketch of graph yet? Here we go. And now, punch out the graph, and there it is. To find the y values, your textbook might leave it as an exact value, 2 pi minus the square root of 3 over 2, and pi over 3 plus the square root of 3 over 2. Or you can go to decimal, just type it out. To find the function value, you put in 2 pi over 3 into the function. In actuality, if you remember from the first section, this would be the absolute minimum right there at the function value of a. And at the endpoint, this would be the absolute maximum. That's why the directions only said find the locals. Those would be the absolute maximum. And that would occur at 2 pi, and the absolute minimum would occur at 0. So keep straight what the absolute is versus what the locals are. Okay? And so you're going to do some trig. We've done the unit circle a couple days in a row now to get you remembering what that's like. All right? What time is it? 20? I don't know if it is or not. I see. I got to pause this. Pause. All right. So, anyway, so that was good. Yeah, I'm going to try again. I'm going to add the thunder to it. And the lightning comes from somewhere else. So, anyway. Last one. Your second set of problems is just basically on the open interval. Okay, we'll get through this, see how we did. Nothing more except the domain is the main issue, and the fact of you being able to take the derivative. I talked to another buddy of mine from Monticello. He can't get him to take the derivative yet. He's getting a little irate. In calc, they're having a little bit of problem. They're having a little bit of issue. I said, we're taking derivatives. I'd say we're running 85%, which is where I should be right now, 85% accuracy if I look at the grades and the test. He's running about 70, so he's got some work to do. He's getting his kids ready for the AP test. I'm getting you ready for the Parkland final. So we're both having an end goal in sight. Anyway, to take the derivative, obviously you need to use the chain rule. You're going to use this rule from now until May. And obviously, yes, it'll be on that final at the end. How many people are taking the final in December? I know 2. Anybody else? 3? Okay. Now remember, you don't. If you're not required to take it, I'll let you take it to raise your grade. Okay. But I haven't gotten a list, or have I got a list? I don't know if I got a list yet. Who has to take it? Other than you two, I know. All right. So I'll take the derivative 1/2. X squared plus 4 with -1/2 times 2x. That's just using the chain rule. And then 1/2 times 2 is just x. Now here comes when it comes to square roots, it's so easy to make a snap judgment about the domain. Plus or minus 2. Well, you got to look at it closely. You're adding here, so it's always going to be positive after you square a number. So this one is going to be the domain we said is all real numbers. So any numbers that come out of here where it's undefined or equaling 0 is going to be a critical number. In that case, we're going to have actually just one critical number. 0 it looks like. Yeah, that's what it looks like to me, 0. So, yeah, that's the only critical number. And then, so all we have to do now is chart it, check the sign of the derivative by using test points into the derivative, and we'll be fine. Obviously, if I put in a negative number, it's going to come out negative. If I put in a positive number, it's going to come out positive because you have the x over there. Now I'd venture to say you could say that's an absolute minimum, but we'll just go with local minimum because it said local extrema. Wait a minute, it did say extrema. I bet that would be an absolute, thinking about it now. So it's local minimum. I would say you could probably say absolute minimum. I'm not sure if I graphed it out, I don't remember. So, the function value, you put in 0, it's going to come out 2 for the y value. If you put 0 into the derivative, it's going to come out 0. That's where it came from in the first place. So 0 into the function value gives you the y coordinate, 0, 2, local minimum. Yeah, I think it would have to be the absolute because y is never going to be negative. Because, yeah, it has to be, since it's a square root, it's never going to be negative. The only thing it can do is equal 2 because of the lift in the problem. All right, these you're going to do on your own. I'm not going to get out the relays. I still got to put in some points for that.
Is this recording again?
Huh? Oh, no, did I? Yeah. Okay. On these 3 questions, do these on your own. I would get out the numbers, but I'm kind of fighting time here. So, yeah, this one's already in here. To find the y coordinates local max or min, you put the critical numbers into the function. Obviously, I didn't change these from the software problem. -3 is inside Rolle's theorem. Rolle's theorem is where the derivative has to equal 0 if the function values are the same. Are the function values the same? Let's see, 5 plus 84, 89 minus 98, negative 11. Is that right? 5 minus 12 is negative 7. Minus 2 is negative 9. I must have said something on my arithmetic on the other one. 5 minus 84, 79. Oh, that's right. Yeah, so they are the same. So if they're the same, then the derivative has to equal 0, and it does so at -3. So that's Rolle's theorem. And then finally, the last one, increasing. Yeah, that's kind of a dud. So that's too bad. 3 things. Do I have enough time for 5 for 10? I think I do.
No.
Yeah, I think I do. I'll forego the 3 things. How about just 1 for all the marbles? 1 for 10.
Can we do 1 for 3?
Yeah.
Odd, making it odd.
I know, we haven't.
What's the question?
Please make it odd.
All right. I only did 12 minutes worth of lesson today.
Great.
Oh, yeah, brain break, and we also did homework questions. Okay.